Start over.
Start over.
Our speaker tonight has some rather cryptic aspects. He sends me emails that I can't understand half
Oh my God.
Is there a lack?
We have a subcommittee in this club dedicated to decoding his emails.
I'm very proud of you.
Yes, Jonathan Cade is the head of that committee. But his emails often stimulate rounds and rounds of emails trying to figure out what in the world is he saying. I have sometimes replied to him in Latin just to get back at him. I use Google Translator to come up with Latin. And you know, he's so cryptic that sometimes he seems to exchange names with Ken Burton. I'm not sure who I'm introducing tonight. He tells me that he has been attending meetings of this club since, I think he said 1962, and gave the third presentation ever, he claims, at a Warren Club meeting. But it was not until about 2005 that Brian Klaus dragged him into club membership.
Good old Brian
He
Klaus.
much more recently has become involved with the Grand Rapids organization, of which he's a member, and to which he will be retiring when he finally sells his house. Maybe.
Past, present, now.
He is somewhat resistant to technology. I think he
You are allowed. That is technology.
He sort of drew the line at telescope technology a few years after Galileo. He does like to host discussion group meetings, but threatens to change the date of them up until almost the last minute. So he tells us, going to be moving permanently, sort of, maybe, to Grand Rapids. And his title tonight is so cryptic, I'm still not sure I know what he's going to be talking about. It's In Search of the Shining Mountain. I mean, is it obvious what that's about?
It's the moon!
The moon is the shining mountain?
There's a shining mountain on the moon.
Well, there's a shining mountain up in Mount Everest, too, you know?
But that's hard to get to.
So maybe we'll be able to figure out what in the world he's talking about during the next hour. Gary, do your thing.
As Dino says, or used to say, when you're drinking till you're stinking, the show looks good to you. Now, as most of you should know, or as Dr. Parton would put it, I am resistant to technology. I point out that the electric light bulb is technology.
So are buttons.
The steam is technology. The steel plow is technology. I use, when in Royal Oak,
Donna, we need some lights on, please.
a 5-centimeter refractor. It's just about all I've used in Royal Oak at my mother's house for the last 20 years, when I started to spend a lot of time around here. There's something to be said for small, simple instruments. I've brought my 5-centimeter refractor here, the Eclipse Special, built in 1973 for the eclipse off West Africa, and mounted on a camera tripod, which I drove over in the car about 1983, and it's never recovered quite since. But when you set your mind to it, and actually we're willing to do a bit of research. It's amazing what you can do with a 5-centimeter refractor in the wretched skies of northern Royal Oak. Such a thing happened to me in the middle of last year, but we'll get to that in a bit. Gentlemen, I'm sure you've all seen, or at least have heard of the moon. Jules Verne. That made a big impression on a 12-year-old when I read that. There's something about a bit of European wit mixed with a strange love of America on the part of that patriotic Frenchman. And my first look at the moon was with an 8-power pair of binoculars that my father bought when he got his first real job in the early 1930s. I still have the drawings I made in the backyard with those 8-power binoculars. Much of the original inspiration came from this volume, once things got rolling. Yet another plug for the Observer's Handbook of the Royal Astronomical Society of Canada. I do it all the time. I can't stop myself. This is one of the finest astronomical periodicals in any language. It's an annual that comes out, and it oozes data. And it was valuable in the progress, or in the application of this mini research project that I undertook. But not only me. I got involved with this search for the shining mountain with my old astronomy mate. He was the fella down the block who, I met him when I was 16, and he had already made a 10-inch Newtonian. He's 5 years older than I am. He'd already made a 10-inch Newtonian. And I got a hold of Martin back in the summer, and I said, there's something we can do together, like the old days. Now he's out in San Diego now, having wisely escaped this state in the late 1970s. He uses his principal instrument as a 6-inch homemade Newtonian in a square wooden tube mounted on plumbing fixtures. A pipe mount. And together, we endeavored to look at something. We had an observing project that we cooked up together, and it was like the old days. Marty and me with our little telescope, or in his case, big telescope, because he made a second 10-inch Newtonian. They don't make them like that anymore, and I'm talking about the men, not the machines. Really diligent, a bulldog, a perfectionist. Very generous with me too, but that's another story. Tennessee Williams. I love the prose poetry. Suddenly last summer, it was on a morning in June. It was just getting light, which is pretty early in June. And I was out in my pajamas using my 5-centimeter refractor on Mom's driveway. And the quarter moon was getting high in the southeast. I was using 45 power. And I was looking at the Terminator, especially at the Alphonsus and Ptolemais region. What a beautiful sight this was, the sun setting on Alphonsus, even with such a low magnification. The central peak was this little diamond in the middle of a great field of black, because the sun had already set on the floor of Alphonsus. Alphonsus has a very considerable central peak. And I was watching it, thinking that eventually this little pinprick of light would disappear as the sun set lower on the moon. And I watched, and it was taking forever, and it was getting, I thought, smaller and smaller, and I got a bit bored, and I looked over on the right. This is inverted telescope. I looked over on the right, which would be the west limb of the moon, and saw the most amazing protrusion. I emphasize protrusion from the lunar limb. I had never seen anything like this before. And at 45 power, it was entirely adequate to get a good look at this thing. And I said something like, wow, what an amazing sight. Now, the immediate moral of this story is that one, be it adverse to technology or not, whatever technology is, someday we're going to have a bit of a go-around about that. Even with such a simple telescope in such a miserable location, if you're willing to use what you have, you can really be an observer. There is this affectation that I first noticed over 50 years ago about what constitutes a quote-unquote serious amateur. And as the boys and I would said it back then, it all seems to revolve around how big a check you're willing to write for your equipment. And that is the determination of who is serious and who is not. To which I say, in my good moments, balderdash. It goes downhill from there. It's an attitude born of consumerism and of false pride. That Marty, with his 6-inch Newtonian in his driveway in San Diego, and I'm not talking about out in the county, I'm talking about near a major intersection, can do things that people who have far higher incomes and better sights are unwilling to do because they're just not that interested. So, some background on the moon. The term libration, as in scale, libration is important in what is to follow. At the 1964 convention of the National Amateur Astronomers, I won a banquet raffle, which was the English language version of the Larousse Encyclopedia of Astronomy, originally published in 1958. And in the Larousse Encyclopedia, for the first time, I encountered the notion, the idea, or the principle of what are called diurnal librations of the moon. In this sense, diurnal meaning daily, within a day. It is as simple as the Earth rotates under the moon in the course of a night, one experiences more or less, I mean in the purest sense, we'll call it a nearly 1,300 kilometer baseline. And in this shifting of point of view, one is looking at slightly different parts of the moon in the course of a night. Think of a full moon rising in the evening in the twilight and setting in the twilight in the morning, say a full moon. And because of this baseline, one is able to look slightly around the moon. It's not very much, but that's called a diurnal libration.
Is that kilometers or miles?
It's kilometers. kilometers. Because I'm getting my data from the Observer's Handbook, and it's Canadian, as it should be. So one has a baseline, and so in the course of a night, and I'm not saying it's easy, I did a bit of a study in the mid-1960s and gave at the 1966 Astronomical League National Convention, for some strange reason nowadays called Alcon. Monsieur Tremblay, I see science fiction influence in this, and I do not approve. It strikes me as
Not guilty!
strikes me as adolescent. I'm old school. That I gave an overlong and not terribly good paper on my observation of diurnal librations with my 6-inch Newtonian. But at least I was in there pitching, not, I would say, with any great expertise. So I've actually tried to observe diurnal librations. It isn't easy, I assure you. Not with equipment like that, and perhaps not with my level of skill, at least as it existed during the second Johnson administration, or if you prefer, the Pearson government. So, we all know, or do we? Notice this, I should write smaller. We all know that the moon presents the same face to the Earth because that she is tidally locked. We see the same face. Well, it reminds me of that line out of The High and the Mighty. We see the same faces at night as we see in the day, except at night they're drunker. So,
Speak for yourself.
yeah. Do we always see the same face to the moon? The answer in the broad sense is yes, comma, but, as they say in the law, on the other hand, there always is another hand in the law. We do not precisely see the same face for two reasons, two mechanisms. The moon's orbit is inclined to the plane of the ecliptic by approximately 5 degrees. The metonic cycle is 19.6 years. So we are able to see the moon looking over her and under her a little bit as the years go by. However, the principal reason we do not always see precisely the same face is because Kepler came along in the early 17th century and threw a spanner into things, in that the moon does not travel at a uniform speed around us. Now, Kepler did not discover that. I mean, that's much earlier. But Kepler came up with the reason why. So, instead of seeing only 50% of the moon all the time, we roughly see 4/7 of the moon's surface over a period of decades from the Earth. It's not 50%. It's a lot more than 50%. So sometimes we see a little bit to the west, we see a little bit more to the east, a little bit more to the south and north. Approximately 4/7 of the moon is visible to us. And once again, comrades, I'm not saying that it's easy, but these features on the rim of the moon all the way around were well documented, or at least decently mapped, not too far into the 19th century. But it's Kepler who did this to us.
This is hard.
I think that's called killing the messenger.
Well, yes, but in politics they do it all the time. I mean, what? Am I supposed to be rational? What? Look at the times we live in. Well, it was once worse, the 1930s, the dirty decade. Moving on. I plead guilty, Jonathan. All right, not to scale, please note that. Not to scale. This is almost a caricature. No, it is a caricature. See that red dot? That suspicious red dot? The big circle in the middle is the Earth. And then we have the moon, appropriately labeled moon. When the moon is farthest from the Earth, it moves more slowly than when she is close. And we don't have to go into the equal areas of Kepler. But Kepler worked out that these smaller bodies in astronomy, be it the planets to the sun or be it the Earth to the moon, do not go around in circles, they go around in ellipses. And when thinking of this years ago now, I thought, how anti-intuitive. Going back, I believe, to the atomists of the ancient Greeks, it was a matter not only of faith, but of demonstration or of logic, that the heavenly bodies move in circles around one another because the circle is perfect and because the universe and the cosmos are logical. That only a circle or a sphere is truly logical. That all of the universe seeks a center. Can only be one center, even if the spheres are concentric. One must seek the center of a circle, and then Kepler comes along using, have I got this right? The observations of Tycho? Do I have that right?
Yes.
Yeah. Mars, right? It was Tycho's Mars observation.
Yes.
Yeah. And said, no, he didn't quite come out like this to say, no, the Greeks were wrong. He said, no, this is the way it really works. And to present the ancient Greeks with something like this would have been cause for immediate rejection. Because how can there be two centers? It's almost painful to think about. There should only be one center, and everything is concentric. In this case, we have essentially two centers. So, because the moon at the bottom is moving more slowly than she is at the top of this ellipse, the moon presents different phases, different aspects, very slightly, in the course of a month. I don't think I'll ever get over this. Now ask a centipede which leg it uses first in moving, and the centipede will become so confused it will stumble over itself and curl up in a fetal position. And this is my reaction to Kepler's work, right? I'll never quite recover from this, I'm sure. See? Kepler. He did it to us. This is the situation as it was last year. Drawn from the last year's Observer's Handbook. The maximum libration of the western limb, these are all of the western limb of the moon, occurs on different dates in a given year. And this is how it went last year. The last quarter of the moon in June was on the 25th, and that was that magic morning when turned the telescope looking for something else and saw the shining mountain on the west limb, and intuitively right by Mare Orientale, the eastern sea. It was, Diane, was it the IAU in 1958, or was it the early 60s, when the lunar designation changed for reasons of astronautics? Because,
the 60s.
sorry?
60s, I believe.
Yeah, all right, because she's our historian of the space programs. That Mare Orientale it would be too confusing for astronauts. So now the eastern sea is by the western limb. These are the maximum western librations, and one can see this is every other month. No sense in spewing out a lot of data. Every other month, and we can see the number of degrees of the moon's sphere changes in these maximum events, and the dates are, well, not all over the place, but it does not repeat. And there were 2 that month in June, 2 maximum western librations. And I was out there on the 25th. 12 December, we will discuss in a little bit. In fact, I don't know whether June was the only month in 2019 in which there are 2 maximum western librations. Frankly, I didn't look that hard at the monthly sheets in the Observer's Handbook. This was the situation on the morning of 25th of June. Again, drawn from the Observer's Handbook. One sees at the far left the asterisk, the red asterisk. That was approximately the subject area of the moon's limb that is presently under discussion. The terminator was pretty much spot on, right down the middle of the disk, and of course the field on the right was in the darkness. We're looking at a last quarter moon. The crater I mentioned that first was the subject of study. It's Alphonsus, right in here. And so one can see why the terminator cutting right across Alphonsus and its neighbor Ptolemaeus, the central peak of Alphonsus, was this little tiny star that was gradually getting fainter, as I said before. And then the eye wandered to the right, and there was this protrusion. This, I cannot describe to you how arresting it was. I mean, how far from the moon's limb, and how bright. I had never seen anything like it. Now, I'm not a real lunar observer like Rick Hill, who makes those magnificent articles every month for the WASP, or maybe in other publications, I don't know. Parentheses. Rick Hill should make a compendium of all his articles, and that would be an education in lunar observing. It would be a wonderful thing if he did that. I'm not in his class, not anywhere near it. He's a real scholar and one hell of an observer and astrophotographer. So maybe Rick Hill would say, oh, I've seen that over the years all the time. Well, this boy really was impressed. With only 45 power, This is a little higher magnification. Well, not magnification, rendering. This is taken from what Sky Publishing put in Sky and Telescope decades ago. It was a reduced version of the Mappa Selenographica done in Europe in 1926. The original Mappa Selenographica was a much bigger rendition. They took it down and published it in the Sky and Telescope, which is a real service to amateur lunar observers. Grimaldi, one can see the arrow, is the principal feature here. Mare Orientale, the eastern sea, right on the limb of the moon, is not depicted on the Mappa Selenographica. It's not even in the index. But there are two mountain ranges in the vicinity of the east limb. The D'Alembert Mountains and the Rook Mountains. And they're both, from this aspect, right on the limb of the moon. Sometimes a little over our line of sight, sometimes within our line of sight. But they oscillate depending on the libration state of the moon. There's that word again. And one notices again that there are two ranges in that vicinity. The Lunar and Planetary Institute in, I think it's Houston, has put online a plethora of lunar orbiter images from the 1960s. And thanks to the excellent system in the Royal Oak Public Library, I was able to look at all of these things and make a decent selection as to which to reproduce here. Now, that thing in the center, that huge feature, is Mare Orientale, and that's the Orientale Basin. And most of the time, it is right on the limb of the moon from our vantage. Keep in mind, we're not looking at a map anymore. We have to orient our point of view. These are now space probe images, and so it takes some adjusting of, well, what we're looking at. Grimaldi, previously mentioned from the Mappa Selenographica, I had an arrow at it, is, as you see off to the left. The line of sight, more or less, is as the arrow depicts. This Orientale Basin is an absolutely striking thing, as we can see from this spacecraft. That's not a craft. I prefer space probe. I'm old school. A spacecraft has somebody inside. We can argue about that at the gin mill later. But I think, what if, with the first advent of telescope observations, what if we had a moon where the Orientale was near the center? What difference might that have made in the evolution of lunar science to see this huge, who knows how big an asteroid it took, what, 100 million years ago? Something? 200 million years ago, to make a feature that looks like that. This huge eye. In fact, it would have probably been visible without a telescope. You see this eye sticking out of the moon at you. Yes, oh yes. Keeps me awake at night. So, because Mare Orientale is so close to the limb of the moon, all we see under the best conditions are some little traces along the limb, just little dark areas. But enough research had been done by 18th and 19th century astronomers that they knew there was some big feature there. They just couldn't see it very well, but they knew that there was some big, roughly round, huge feature on the moon. And so they gave it a designation of a C, which is a major designation for lunar features. But that's the way we look at that whole region of the moon from Earth-based telescopes. This is a little more conventional. And as I described, that most of the time Mare Orientale are these little traces by the limb. And Grimaldi is the large dark feature, as I have delineated off to the right. But notice the brackets. Regardez. Well, I can butcher French with the best of them. That is the area of interest for looking at the shining mountain, or looking for the shining mountain. Oh. I'm old school. North is always at the bottom. Oh, for Christ's sake.
I think you're a little too old school now.
What?
It's
never happened
like
with
it's kind of required.
There you go.
See, he loves technology.
Yeah, as I say, you want to talk technology? I'll tell you about the steel plow. Do you think that made a difference in human existence? A lot more than this. Whoa! Whoa!
I'm surprised you're not riding a stationary bicycle to power this thing.
Now, this is a really high magnification lunar orbiter view, I think 1966. And one sees over here. See that? Well, that's the way it looks from space. Doesn't look like that in my 5-centimeter refractor, but I do believe that there is a close relationship. And sees that it's tough to read at the very top. At the very top of the picture is a portion of Mare Orientale. There's something going on there that somebody ought to know about. So before reading into the record the full roster of observations, to give you the punchline here. Throughout the summer and into the autumn, there was some confusion for Marty and me and what we were looking at, because we weren't sure whether the shining mountain was close to Grimaldi or close to Mare Orientale. We developed our own nomenclature. There's the shining mountain and the false shining mountain. And there was some genuine confusion because we don't have the best of of source material. And even if we had, it would be to us strings of pearls to apes. But we enjoyed our confusion and our exchanging of notes. This is a research enterprise that spanned a continent. It may have been a little primitive to look at, but this is, well, when dancing, think Fred Astaire. So we had the shining mountain and the false shining mountain. After a very long time, taking it into December, I put the 16-inch at the Wien Observatory on it, and this is what transpired. I saw them both. Now, to be fair to Martin, he's got only a 6-inch Newtonian, and so I telephoned him and reported what I'd finally seen. That there was a false shining mountain. The real shining mountain is farther to the south. And this is crude, but a decent representation of what things looked like that night last month. The moon was approximately 3 to 4 hours short of full. We had a really full moon, well-defined limb, no terminator, and at 200 plus power, it was striking how much brighter the real shining mountain was compared to the false shining mountain. They were both slightly sway-backed, slightly camel-backed, but the albedo of the true shining mountain was striking, which is why it stuck out so dramatically in a small telescope in June at the last quarter. And herewith is the chronology. The seeing was really good. The moon was high. I was not expecting the seeing to be that good, but it was. It was as rock steady as one could want at that magnification. I could see the crenulations in both features on the slopes that were presented to Earth view. In other words, the way the mountains actually spread out with whatever that feature would be called, with like toes or something, or limbs. It was excellent seeing. And the shining mountain was really bright. It was white. The false shining mountain was basically pearl gray. But there was real confusion for a while. And so, I would read some of this into the record. What am I holding? This is a piece of the true cross. In medieval times, you would cross yourself and genuflect. This is a sacred object. Only I may touch it. You may look, but not touch. This is the logbook from the James C. Wien Observatory. That's right. Right. I feel like a conquistador showing this to the great Inca, you know, and expecting him to fall on his knees. Right. We keep him to last. No, we don't put stuff in the cloud. Because, as Dr. Parton would say, some great coronal mass ejection will come and make a hash of all your cloud satellites, right? It'll turn into mush. But this will prevail. That's right. So, how's that? Well, as George M. Cohan, when he saw the premiere in which James Cagney portrayed him, Yankee Doodle Dandy, he said, now that's an act to follow. So, here. I will now read you the truth. From paper,
Wow,
the truth.
what was combustible paper?
Truth. Fahrenheit 451 is one of my favorite stories going back to the teenage years, because I was never particularly good in school, and I thought, it'd be a better world without all those books, wouldn't it? I'm going to sign right up. So what have we got here? All right, the 23rd of August, I had my telescope out in Kent County. From Cascade Road, from Cascade Township on snow with 5-centimeter refractor, last quarter moon, did not see the shining mountain on west limb, 45 magnification. The moon with cirrus, difficult conditions, the 17th of September, Tuesday. '21st of September, Saturday. Shining mountain at twilight, last quarter, 30 power with 10-centimeter refractor. That's the Veen Observatory. Nothing, but only a slight bright spot on the limb. 85 power confirms. Tiny bright region in D'Alembert Mountains, but no protrusion. Out. Dawn. Damp. 19th of October, possible sighting of shining mountain in 10.2 centimeter refractor, 26 millimeter eyepiece, same latitude as Mare Orientale. At this point, there was mass confusion for Marty and me, what we were looking at, whether it was the true one or the false one. Same latitude as Mare Orientale, out 0735 universal time, fell on face on the observatory road. Yeah, that hurt. 22nd of October, observe the shining mountain, not as good as in June. Latitude same as Grimaldi. No, sorry. Grimaldi is too far north. North of Orientale, traces, 10.2 centimeter refractor, 40 power finely. No, not finely. Shining mountain, 23rd of October, seen, 40 power and 10.2 centimeter. Smaller other limb deformations to the south, all dark Orientale tracings visible. And cutting to the chase here, isn't that from horse racing? Yes. 16th of November, 10.2 centimeter at 9.7 centimeter eyepiece, shining mountain likely, full Orientale markings nearby, second mountain farther north. At that point, we knew that there were two features. There was the true shining mountain and the false shining mountain. So, this, I am sure, all is not revolutionary in the course of lunar science. This is amateur astronomy, amateur science. And Martin and I had a good time with this. We could do it under miserable skies from a driveway with small, even primitive telescopes. And we both learned a lot about lunar astronomy, or at least the effect of librations, that even an amateur can observe and make something of. Now, can somebody give me the time, please?
8-2.
8-2. All right. Well, as The saying goes, not to change the subject, which means that's exactly what I'm going to do. The Measure of the Moon by Ralph Baldwin. This is from the library of the Wien Observatory. Ralph Baldwin is a fascinating and accomplished man. An astronomer, 1963. In my view, this is the greatest book on lunar astronomy in English that was produced in what we nowadays call mid-century. He's a Grand Rapids man. Comes from an industrialist family, business class. Never met him. And there's a reason why. Old industrial family. Wealthy. A friend who also, now deceased, the Galaxy Observer I've told you about. Real friend. He preceded me to the grave by far too many years. This was almost 30 years ago. His family and Ralph Baldwin and others were at a dinner party, I think in East Grand Rapids. And my friend was quite anxious to meet the famous Ralph Baldwin, and sought him out in discussion about astronomy, and found, if my memory serves, that he was not terribly interested in any of this anymore. This was in the early 1990s. And someone asked him, Baldwin, why he didn't get involved with the Grand Rapids Astronomical Association. Right. Parentheses. It was Scott Fitzgerald who said, I looked for it, The Great Gatsby, couldn't find it. See if I can recite it. The rich are different. They are soft where we are hard. They are cynical where we are trusting. The rich are different. Baldwin's reply was, I didn't want those guys to come to depend on me. We need not detain ourselves with Ralph Baldwin. Thank you.
We have just a couple of minutes for questions.
Well,
I have a question if no one else does.
I'll bet you have many.
So, you have seen the shining mountain with your 5-centimeter refractor, true?
Yes.
How much more clearly could you see it with the 16-inch at the beam telescope?
Vastly. Because this was in excess of 200 power under really good sleep. That's why I could see the contours on the face of the things, both of them.
How clearly could you see the shining mountain?
My screen isn't as bright as I think it is.
Just as a protrusion. It was a protrusion. It was a big bump on the limb of the moon.
Okay, not a sharp bump, but a spread out bump, right?
Yeah, it's a mountain. It's a squat isosceles triangle, right? You know, it's. Oh.
Technology don't work.
Well, there's no way for you to project this.
No. I
See, it's right by the Lake of Autumn. I wasn't familiar with that feature.
What was the date?
What?
June 25th?
So the last quarter date, yes.
If anyone wants to see it, see me after, I guess.
Okay. I'm just trying to get a sense
If you want to
of.
see it, you have to do what Gary did.
Well, that's true. If
that's
you want to
not
really
seeing
see it, this is not seeing it, but this is getting a sense.
I mean, I'm just trying to get a sense of how difficult it would be for those of us that don't have a 16-inch instrument to look for it, you know?
You know, it would be easy, it's just that the libration has to be right. The moon has to be in the right position to present that thing on the limb, not over the limb, not in front of the limb, because it will blend in. So it's easy to see in a 5-centimeter refractor. And it's also relatively easy to see the false shining mountain too, which is why there was this confusion.
Okay, any other questions for Gary?
Whose
Any,
phone is this? That's mine.
any plans for Eastern libration expeditions?
No, I'm sufficiently freaked out by this. That's a good question, you know, in all seriousness. Not at present, but it would be something worth doing. Yes.
You were speaking earlier about the intensity or the passion for the hobby and purchasing equipment. That this separates maybe the men from the boys more or less.
He was saying otherwise. He was saying that.
But would it maybe also be how much time how many man hours you're willing to invest in the study of the
Absolutely. That's the most important thing right there. How much you are willing to get involved and get your hands dirty and be out there in your pajamas, in no shoes when it's snowing or whatever. Right?
Okay, let Gary do that, but it's definitely the time.
Okay, Ken?
Question I have is, where are the estimates on the age of that asteroid coming from, or whatever hit the moon, obviously, hit it pretty
It was sometime after the Mare Imbrium impact, so the impact would have been about 3.5 billion years ago.
Okay, I was saying the million years.
No,
So I was way too short. I said 100, 200 million years. No, that's yesterday.
Yeah, that is yesterday.
Right.
You're just guessing.
Thank you for that, Diane.
Probably during the period of time when they said something hit it.
No, it was the last significant, I believe this was the last significant impact on the moon. So we think of Mare Imbrium as being the last big one.
Sure.
This was sometime after Mare Imbrium, hence the perfect bullseye instead of a traditional Mare sort of a look.
Okay, good.
So I'm saying 3.5 because that's newer than 3.85.
Okay. So where are we putting this in the documentation of when the moon hit the Earth, or whatever, or what?
Oh, well,
when what you call it?
We were still plastic at that point.
How much later was that? Was that about 4 billion years ago that the Earth got collided with the Theia or whatever?
That was almost 4.5 billion
4.5
years ago.
billion. Okay, so very early in the formation. Okay.
I mean, this really was the start of the
This
story.
is much later.
Much
Well,
later,
listen,
at least a billion years later.
That's what I was looking at.
Do you have something real quick?
What we see, that shiny mountain, the true projection, and we have pretty good idea size of the moon. What would be elevation of that mountain? Any idea at all?
I haven't got a clue. If I had, in the old days, a filar micrometer, I could have made measurements. Not with a 5-centimeter refractor, I assure you, right? But I have no idea, but I reckon that contemporary lunar charts, especially from space probe data, has established the altitude of these things very accurately. But I don't know.
I would comment, if you just look at the picture Jonathan has on his phone, compare the curvature of the moon to the side, you could get
I know the size.
a rough
It's about
estimate.
1/4 of the
I-
Earth, is that right?
I'd
About
like
1/4.
to just sum this up by saying a lot of us who are into astronomy here, we're trying to find galaxies and star clusters and look at features of planets and things like that are a little more challenging. But right in front of our faces, close up, is the moon with a rich diversity of features that are easy to see even with a modest telescope. And I would say to some extent Gary has made me more aware of that, and more appreciative of all the interesting features there are on the moon and how they change with where the terminator is on the moon and things like that, that will highlight features as the sun comes in at a grazing angle. I mean, I think there's a lot to see there, and it's low-hanging fruit. It's relatively easy to have fun projects, to look for things on the moon. It puts me in the mind of trying to find a book I can buy that will sort of point me in the direction of interesting things to look at. Anyhow, thanks again, Gary.
Thank you.
Who has looked at 5 named features on the moon whose names they knew? Okay, so that's 1, 2, 3, 4, 5, 6, 7, 8. Okay, 10. 1, 2, maybe? 15. So there's a lot of work for us to do on the moon, and it's so easy, and you can even see it through the clouds a lot of the time. So
And Jonathan would be very happy to send in your data for the Astronomical League Lunar 100 observing project.